I'm actually recording this so you guys could have it later as a source, right? To see how to study for the test. So this is rule 3, where you take the outside exponent and distribute it to each and every inside exponent, right? Now, this is not the number 4. It's not the number 4. I mean, it is a number 4, but it's an exponent. It's not a regular number. It's an exponent. So it's not 4 times 2. It's the exponent of 4 that you're going to put on the 2. So that's going to be 2 to the 4th power, okay? And then you're going to put the exponent of 4 on that exponent of 3. And rule 2 says a power to a power you multiply. So that's going to be x to the 12th. And then power to a power right there. Put the 4 on the 5, power to a power, multiply. You get y to the 20th. Now, the only other thing that you could do to make this look nicer is to actually do the 2 to the 4th, which is not 8. That's really 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So you really should put a 16, and then you got your x to the 12th and your y to the 20th. So there is your answer, 16x to the 12th, y to the 20th. Same as rule 3, this is rule 4. It's simply whenever you have parentheses with an exponent on the outside, you distribute that outside exponent to each inside exponent. So you're going to take this 3, you're going to put it on the 2. Again, that's not the number 3, that's the exponent 3. So you're going to have 2 to the 3rd up on top. Put the 3 on the 7, a power to a power multiply, x to the 21. Put the 3 on the 3. It's not 3 times 3, it's actually 3 to the 3rd, right? And then put the 3 on the 4, power to a power multiply. 3 times 4 is 12. What else could you do? You could simplify 2 to the 3rd. That's 2 times 2 times 2. And you could also do 3 to the 3rd, which is 3 times 3 times 3. So our final answer up on top will be an 8, because 2 times 2 is 4 and times 2 is 8, x to the 21. And on the bottom, when you go 3 times 3, that's 9, but times another 3, that'll be a 27, and y to the 12th. Of course, you're supposed to try to simplify. Like if this were an 8 and a 24, you could reduce that, but 8 and 27, you can't reduce. So this is your final answer, 8x to the 21 over 27, y to the 12th. This question right here is specifically with rule 6. Anything with a negative exponent must be moved to the other side from numerator to denominator or denominator to numerator. So you should recognize that x has a negative exponent. 7 does not have a negative exponent. So you circle the x to the negative 2, and you draw an arrow to the other side of this fraction. What fraction? Just put a fraction bar and you have a fraction. So you're going to take that x to the negative 2, you're going to move it down. It's going to become x to the positive 2 when you move it down. So it's no longer up on top. And that is your answer, guys. Like you have a fraction. What's on top? A 7. It didn't move. What's on the bottom? An x squared. So if you look at the answer here, provided 7 over x squared. That is your answer. Nothing else to do. It's like a free point on the test. On this question, we have the negative exponent rule that you have to move to the other side. And you also have the canceling rule, which you have x's on top and x's on the bottom. You could cancel things out. And you have these regular numbers. And regular numbers in a fraction is really a division problem, right? And if you can't divide, then you could at least reduce the fraction. So let's begin with starting with the negative exponent rule. You take this guy, you move it down. You take this guy and you move it up, okay? So I'm just going to rewrite it. And then from there, we could do the last rule of exponents, the canceling rule. So we have x's on top and on bottom. So you could cancel out all 7 x's on the bottom with 7 of the 9 up on top. That's why there's 2 left, okay? So you could, I mean, if you want, you could visually draw out 7 x's, x times x times x, 7 of them, and then x times x times x, 9 of them, and then all 7 will cancel with 7, and you're only gonna have 2 left over. It's easier, instead of drawing them all out, to just subtract. 9 take away 7 is 2, and where's it left over? It's up on top. Now, if the 7 would have been on top and the 9 would have been on the bottom, then it would have had a 2 left over on the bottom. So I always like to visually think of canceling, at least in my head. 7 cancel with 7, there's 2 left up on top. Same thing with the y's, we're going to cancel them out. We could cancel 7 of the y's, all 7 y's up on top, cancel with 7 of the 8 on the bottom, leaving me 1 left on the bottom. Now, in addition to that, we're going to look at this fraction, 16 over 8. That's 16 divided by 8. That ends up being the answer 2, and it's up on top. So that cancels, you have a 2 up on top. So your final answer is 2 x to the second over y to the 1, which you don't need a y to the 1. There's your answer, 2x to the second over y. On this question, we have several rules. We're gonna first use the anything to the 0 power cancels out and it becomes 1. So we're just gonna scratch that out. I mean, yes, you could put a 1 times right there, but it's not gonna change anything. So it's better to just scratch it out. And then what else do we have here? We have negative exponents. So we could take this and move it to the bottom and then cancel, or we could use rule 1 and combine them and then move. It's totally up to you. I'm going to move the x to the negative 12 to the bottom, and it's going to become x to the positive 12. And if you're thinking the bottom of what? The bottom of the fraction, just put a fraction bar, move this guy down, and it'll become x to the positive 12 down there. So you're going to end up with x to the 6th over x to the 12th. And what is x to the 6th over x to the 12th? You could now cancel using the last rule of exponents. All 6x's cancel with 6 of the 12, leaving you 6. So whenever there's nothing left up on top, you have to put a 1. And on the bottom, you have an x to the 6th. And that is your answer, 1 over x to the 6th. On this question, there are many options. You could distribute the negative 1 to each and every power, but I'm not going to do that. In mathematics, it's a good idea that whenever you have parentheses, I mean, the parentheses tell you to zoom in and do whatever you can on the inside. So looking at the inside, is there anything I could easily do? Absolutely. We have z to the power of 0. We know that that becomes a 1, so you could just scratch that out. That is gone. It's no longer there. There is no z. Okay. What else could we do on the inside? Well, we said that anytime you have a negative exponent, you're supposed to grab that term and move it up to the top. Okay, so I'm going to take that y to the negative 4, and it's going to become a y to the positive 4 up on top. So now I could just scratch it out from the bottom. I already moved it to the top. It became y to the positive 4. So what other rules could I do? Well, I also have x's on top and x's on the bottom, so I could cancel those x's out. So I'm going to cancel all 4 x's on the bottom, completely cancel with 4 of the 9, leaving you 5 left over up on top. In addition to that, is there anything else I could do? Yes, I could actually multiply y to the second times y to the 4th. That is rule 1. Rule 1 says that when you're multiplying with the same base, both y's, you could simply add the exponents. So I know it looks like a hot mess, but let's rewrite what we have so far right here. We have the 3x to the 5th, and we did say that y to the second times y to the 4th, you add the exponents, you're going to get y to the 6th. And it's over, everything moved up, canceled out. There's only a 2 down here. And that is good. Now, at this point, you could, if you wanted to, put this power of negative 1 on the 3, on the x to the 5th, on the y to the 6th, on the 2. Everything would have a negative exponent. Then you'd have to move everything, right? Or another trick that you could do, another trick you could apply is whenever you have a negative exponent on the outside, you can simply change it to a positive as long as you flip the whole inside fraction, okay? As long as you flip it. So in other words, you're going to end up with a 2 on top, a 3x to the 5th, y to the 6th, and now this is a positive 1. Now, if this would have been a negative 2 to start with, then this would now be a positive 2, and then you would distribute that positive 2. But distributing the power of 1, it doesn't change anything. So technically, you don't need it. This is your answer right there. Let me show you. There's the answer. 2 over 3x to the 5th, y to the 6th. This one has a lot of rules that you have to apply. Multi-step, right? Let's begin with the parentheses with an exponent on the outside. You have to distribute that. You can't cancel out y's yet because this y is inside parentheses. So you have to distribute the exponent, in this case, negative 3. Put the negative 3 on the 2, 2 negative 3. Put the negative 3 on that negative 4. Remember, a power to a power multiply. So you have a negative 3 times negative 4. That's a positive 12. It's no longer negative. Put that negative 3 on the y. That'll be a y to the negative 3. And that's what you have up on top after distributing the negative 3. The bottom, I'm just going to leave it the same for a little bit. We got a 3, x to the 0, y to the 5th. Okay, so we applied one rule. What else could we do? Well, there's another rule that says when you have a negative exponent, you have to move it to the other side and it becomes positive, right? So we're going to take this 2 to the negative 3 and we're going to move it down. But when you do move it down, it's going to become positive 2 to the positive 3. We're going to take this y to the negative 3 And we're going to move it down, but when you move it down, it's going to become y to the positive 3. Okay? So the 2 to the negative 3 is no longer up on top. It moved down and it became 2 to the positive 3. The y to the negative 3 is no longer up on top. It moved down and it became y to the positive 3. What else could we do? Well, whenever you have a power of 0, that's the easiest rule out of all of them. That just becomes 1. You could just scratch it out. X to the 0 is gone. Okay? So what do we have? We have an answer so far. Up on top, what's left? There's just an x to the 12th. On the bottom, what's left? Well, we still need to simplify. You see, what is 2 to the 3rd? That's really a 2 times 2 times 2. And then you got the times 3. So what is 2 times 2? That's 4. Times 2, that's 8. Times 3, that's 24 at the bottom. Or he could have also said that's 8, and 8 times 3 is 24, okay? And then we're also going to use rule 1, that when you have y to the 5th times y to the 3rd, add the 5 and the 3, you get y to the 8th. And ladies and gentlemen, there's nothing else to do. That's why the answer is exactly that, x to the 12th over 24, y to the 8th. On this question, we are selecting all the true statements. When graphing an exponential growth function by hand, you should use consecutive integer inputs like -3, -2, -1, 0, 1, 2, 3. Yes, if you're graphing it by hand, it's great to use these, especially if you're ignoring h and k. That way you could use the growth or the decay factor to get other outputs. It's a lot faster if you're using these consecutive integer inputs. So I would select that one for sure as a true statement, okay? Actually, check. So that's good. How about the next one? The asymptote is the line that your graph will infinitely approach but never actually touch. That is 100% correct, right? And then the next one, it says the asymptote is the line x equals k. Well, let's think about this, guys. The equation is y equals a times the base to whatever power x. In algebra 2, you'll have a minus h, but in algebra 1, you just have the plus k. Okay, now, what is the asymptote? It's the horizontal line y equals k. And if you look up here, it doesn't say y equals k, it says x equals k, which is incorrect. So you got to pay attention to that detail. So this guy is not right. Don't pick that one, okay? And then the next one, the range of any exponential growth or decay function is y equals all real numbers. That is totally false. The domain is x equals all real numbers, okay? But the range, it's always going to be either above or below your asymptote, okay? So for example, if I had, let's say, y equals 1/2 parenthesis 2 to the x minus 3. Well, we would graph it by going to the minus 3 on the y, drawing your asymptote. And then this is a growth function. You could plug in a 0 and you'd get out 1. But the reality is you're going to end up with a graph that is above that asymptote. Okay, so right there, the range would be y is greater than the asymptote value of -3. That would be the range for that particular example. So the range is not y equals all real numbers. It doesn't go up and down forever. It's all going to be above the asymptote or maybe below the asymptote. And that technically depends on your a value. If it's positive, it's above your asymptote. If it's negative, if the a value is negative, it's below your asymptote. So this one did require some explanation. I apologize. So yes, this one is not correct either. So only the first two were correct. This one's an easy question. It's asking for the range, and the range is simply either above or below your asymptote. So as you can see on this graph right here, the asymptote is at y equals 4. So this line right here is at y equals 4, and you could clearly see that the graph is below that y value of 4. So how do we say that your y values are below the y value of 4? You say y is less than 4. That's why the answer is y is less than 4. Once again, we are selecting all the true statements. So this is a decay function. Is that true or false? That's false. How do you tell if it's growth or decay? The base, the b value. if it's bigger than 1, it's going to cause it to grow. And that makes total sense. Anything times 2, your age times 2, what happens? You're older, right? Anything times 2. You have $10, multiply it by 2, it's $20. It grows. So anything that's bigger than 1 is going to cause it to grow. That's a 2, that's a growth function. A 3, a growth function. A 5, a growth function. A 1/2, that's not a growth function. That would be a decay. So it's that simple. The base, if it's bigger than 1, it's going to cause it to grow. If the base is a fraction between 0 and 1, less than 1, it's going to cause it to decay. So this is definitely not a decay function. This is a growth function, so don't pick that one. What does it say? This has the y-intercept of 1/2. Well, in order to find the y-intercept, in case you don't remember, in order to find the y-intercept, you set x equal to 0 and solve. Okay, so we're going to put a 0 where the x is at, put a 0 there, and then you're going to do the math. 2 to the 0 is 1, and 1 times 1/2, 1/2 times 1 is 1/2. So when you plug in a 0, you do get out a 1/2. So it's saying that it has a y-intercept at 1/2. Absolutely true. It's at 0, 1/2. Okay, so this guy is true. Check. The asymptote of this equation is y equals 0. Well, we need to know that the asymptote is y equals the k value, the number that's being added or subtracted at the very end. And in this case, there is no number. So yes, it is true that your asymptote is y equals 0. If you would have had a 3 right here, your asymptote would be y equals 3. If you have a -4, y equals -4 would be your asymptote. Since there is no number, you could put a +0 and say that the asymptote is y equals 0. The range we've explained before that it's either above or below your asymptote, and it's depending on your a value. Okay, wait a minute, I forgot to check this. That's correct. So the range, it's either above or below your asymptote. And how do you know if it's above or below the a value? If it's positive, it's going to be above. If it's negative, it's going to be below. So this is positive, so it should be above. And that means that your range should be y is greater than, because it's positive. And right here it says y is less than. So this is false. Okay, so only the 2 middle ones are correct. Yet another select all true statements. Now, I did put this little picture up here in case you forgot what quadrants are what. It's quadrant 1, quadrant 2, quadrant 3, quadrant 4 on your screen. You could blow that up to make more sense of it. So we're going to begin with this one, reading this one. Y equals 2 to the power of x minus 9 will never touch quadrant 3. So that's this quadrant down here. So let me just draw it a little bit bigger. This is quadrant 3, okay? And it's saying that this equation will never touch this quadrant. Now, the asymptote itself is at -9. So technically, you would go down 1, 2, 3, 4, 5, 6, 7, 8, 9, and your asymptote is right there. And you know that your graph will infinitely approach or grow away from that asymptote. So since it's in quadrant 3, you already know it's going to be crossing into quadrant 3. It's going to look something like this, the graph. So that's definitely in quadrant 3, so that's false. So don't pick that guy. It will touch quadrant 3. How about the range? Well, the range of this guy, we know that it's either above or below the k value, -3. And in this case, the a value is positive. There is no a value. It's +1. So this is going to be y is greater than -3 because the a value is positive. So that's a true statement. If you would have had a negative out here, then that would be y is less than -3. But because the a value is positive, it's y is greater than -3. So this is a true statement right there. Check that. True. And then this next one, if b is any fraction, then it must be an exponential decay function. That is false. Now, why is that? Because you could have y equals 3/2 x plus, let's say, +1. The reality is this base, it's a fraction, but that fraction is greater than 1. 3/2 is 1.5. If you multiply anything by 1.5, it's going to grow. So it is false that if the b is a fraction, it must be a decay function. That's not true. This is a fraction, and it causes growth. Anything times 1.5 is going to cause it to grow. So this was also false right there, this guy. So the only correct answer is the range. Once again, when they ask you to state the y-intercept you got to remember that you have to set x equal to 0 and solve, okay? So you're going to rewrite this thing, y equals 2 to the, and you're going to put a power of 0 on the x, and you're going to solve it. So what is 2 to the power of 0? That's really just a 1. So you really have 1 minus 4, and that's a negative 3, okay? So what is the y-intercept? It's 0 because you set x equal to 0, and you got out a negative 3. So 0 and negative 3 is the answer. That's why that guy is marked in green, because that is the answer, none of the other ones. Which of the following are exponential decay functions? Well, the key word is distance. Distance, okay? And you also need to know that you look at graphs the way you read a sentence from left to right, okay? So if you're looking at each graph from left to right, and if you look at the distance from the graph to the asymptote, it looks like the graph is touching the asymptote, and from left to right, the distance is growing. So this is a growth function from left to right. Once again, it looks like it's touching the distance between those red dots, which is the graph and the asymptote. It's growing. So that's a growth function. They're asking for decay functions, not growth functions. So this one from left to right, there's the distance. It's pretty big. From left to right, the distance is decaying. It's getting closer and closer and closer. So this is a decay function right here. Actually, I should do that in green. That's a decay. This was growth, so don't pick that one. This guy, from left to right, the distance from the graph to the asymptote, that's a pretty big distance. From left to right, what's happening? The distance is decaying. So this is a decay function as well. This is decay, decay. And this last one, it looks like they're touching. From left to right, the distance between the asymptote and the graph keeps growing. So that's a growth function, not a decay function. So it's a growth. So on the actual test, you're going to have two of these questions, one where it asks you to identify the growth and one where it asks you to identify decay. This question is even easier than the previous because right here you're asking for which one's growth, which one's decay. It's this simple. If your base is greater than 1, it's going to cause it to grow. If your base is less than 1, it's going to cause it to decay. So don't think that if you have a fraction, it's automatically decay. In this case, the fraction 10 over 9, that's bigger than 1. Do that on a calculator. It's going to be 1.1 or something like that. It's going to be bigger than 1. That's a growth function. So they are asking for growth. That's just saying for any base that's greater than 1. So this one's definitely growth. This one's definitely growth. This one's definitely growth. This guy is not growth because that's a decay function. Another question on range. So what we need to know about range is that the range will either be above or below your asymptote y equals k. If a is positive, it's above. If a is negative, it's below. Remember, your a value is the number that's out here in the front. In this case, the a value is an invisible 1. It is positive, so it's going to be above the asymptote y equals k, which in this case is 4. So how do we say that it's above the asymptote y equals 4? You're going to say that all of your y values must be greater than that k value, 4. Okay. And again, it's only greater than because the outside value, the a value, is positive. If the a value would have been negative, then this would have been a less than because it'd be below. Once again, the a value is positive, it's above. If the a value is negative, it's below. And right here, the a value, maybe I should write this out. The a value is clearly the number 1, so it is above. That's why when we look at our multiple choice answers, it would be y is greater than 4. And as you can see, none of these are y is greater than 4. So none of these are correct. On this particular question, I'm just checking to see if you know how the growth or the decay factor work. I tell you which outputs correspond to the inputs, -3, -2, -1, 0, 1, 2, 3. I even show you an input-output table. And of course, that's what I want you to plug in. -3, what do you get out? -2, what do you get out? But if you understand the growth or the decay factor, all you have to do is plug in one simple input and get out one simple output, and then you could use the output and make it grow or decay by this growth or decay factor. So once again, we're going to start by doing -3, -2, -1, 0, 1, 2, 3. Then you're going to plug in your easiest input, in this case 0, when you plug in 0, anything to the 0 power is 1. So 1/2 to the 0 power is 1. And 1 times the a value of 4 is 4. So when you plug in 0, you get out of 4. Now, after that, you don't have to plug in a 1 right there and do the math, a 2, do the math, or a -3, do the math. All you could do is, or what you could do for that'll be a lot quicker, is understand that this base is less than 1. It's a 1/2, which is going to cause it to decay. So this output is going to decay to get to the next one by 1/2. Okay, if it were a 3, it would grow by 3. If it were a 2, it would grow by 2. But it's a 1/2, so it's going to decay by 1/2. So if you go 4 times 1/2, it's going to decay down to 2. If you go 2 times 1/2, it's going to decay down to 1. If you go 1 times 1/2, it's going to decay down to 1/2. And if you're going backwards, instead of multiplying by half, going backwards, it would be multiplying by the reciprocal of half, which is multiplying by 2. In other words, the opposite of dividing by 2 is multiplying by 2. So once again, if you're multiplying by half going this way, because that's your decay factor, going backwards, it's going to be multiplying by the reciprocal, which is 2 over 1, which is 2. So 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So when they ask us to state the corresponding outputs to -3, what corresponds to -30? 32. What corresponds to -2? 16. So this list, 32, 16, 8, 4, 2, 1, 1/2, that's the list that you want to represent the outputs that correspond to the given inputs. We finally get to some graphing exponential growth or decay functions. Once again, you start by identifying your asymptote, which is the k value, which is the number that's being added or subtracted at the very end. Since there is no number, you could put a +0 right there. So we know that our asymptote, this line right here, you're going to have to shift it up to this location. However, when you try to move this up, it won't let you because there's a dot already right there. So what you have to do is first move this dot somewhere else. Let's say right there, and then you could move it up, and then it'll be right there, the asymptote at the k value 0. And then from there, you need to do get an input-output table, an XY table going, and it's really simple. Plug in some easy numbers like 0. So if you do plug in a 0, 3 to the 0 is 1, and 1 times 2 is 2. And if you did +0, it's still 2. So when you plug in a 0, you get out a 2. So that's one of the points. So take this guy and move it to 0, 2, which happens to be actually already at 0, 2. So that point is good. Now let's plug in a 1. You could technically plug in any numbers you want. Plugging in a 1, 3 to the 1 is 3. 3 times 2 is 6. So when you plug in a 1, you get out a 6. So you're going to take that second point and you're going to go to 1, 6. 1, 2, 3, 4, 5, 6 right there. And with those two dots and with the asymptote, you're already going to get your perfect graph that looks like that, which is an exponential growth function. Okay, let's move on. Once again, you begin by identifying your asymptote. Your asymptote is y equals k, in this case, y equals 4. So you're going to drag the asymptote that's currently at -2, you're going to move it around to +4, and you're going to leave it right there at +4. And then from there, you're going to do a quick XY table, plug in some easy numbers like 0. And if you do plug in a 0, and you're plugging it into the whole thing, you're not ignoring the k value, plugging into the whole thing, plug in a 0 right there. 5 to the 0 is 1. 1 times -2 is -2, and -2 plus 4 is +2. So when you plug in a 0, you get out a +2. If you're confused about that math that I did right here, you could type it into a calculator. -2, open parenthesis, 5, close parenthesis, go to the exponent, plug in a 0, get off of the exponent, hit the plus sign, hit the 4, hit the equal sign, and you will get 2 as an answer. So the input 0 gives you the output 2. So you're going to simply move this point that was at the origin, you're going to move it to 0, 2, leave it right there. Then you're going to do one more easy input, like let's say the number 1. Plug in the number 1 right there. 5 to the 1 is 5. 5 times -2 is -10. And negative 10 plus 4 is negative 6. So when you plug in a 1, you could get out a negative, you do get out a negative 6. And once again, you could use a calculator to get that output negative 6 for the input 1. So let's go to the location 1, negative 6, and let's drag the second dot to 1, negative 6, which would be right here. And just with those two dots, you're going to have the perfect graph produced on Desmos. Okay, so that is what your exponential growth function looks like. And let's move on to the next question. Once again, let's begin with the asymptote, which is y equals k. Y equals negative 7 is the asymptote. Right now, currently, the asymptote is at y equals negative 2. You need to move it to y equals negative 7. So grab the asymptote, move it down to negative 7. And then from there, you're going to plot 2 points. How? By doing an XY table with the entire function. All right, you're not ignoring the k value, you're including it with the entire function. So let's plug in an easy number like 0. When we plug in 0, and again, you could do all this with the calculator. I want to do it explained right now in my head. 1/2 to the power of 0 is 1, and 1 times 6 is 6, and 6 minus 7 is negative 1. So when you plug in a 0, you get out a negative 1. And once again, you could type in 6 parentheses 1 over 2 close parentheses power, hit 0, minus 7, hit the equal sign, and it should give you that output negative 1. So the input 0 gave us the output negative 1. Let's take this dot that's at 0, 0 and move it to 0, negative 1. There it is. Let's do the next input, let's say of 1. You could technically plug in any number you want, but you might as well try 1. It's pretty easy to do. When you plug in 1 into the x, that's 1/2 to the 1 power, which is just 1/2. What do you have here? You have 6 times that just 1/2, right? What is 6 times half? What's half of 6? It's 3. And what's 3 minus 7? That's negative 4. So the input 1 gives you the output negative 4. So I'm going to take this coordinate and move it to 1, negative 4. Here we go. From 0, 0, 1 on the x, negative 1, 2, 3, 4 on the y. And that is it. With these two dots and with this current asymptote at negative 7, the Wayground quizzes will graph it for us. It's like this, going down, infinitely approaching the asymptote. Arrow going that way. Let's move on to the last question. Just like always, start with the asymptote. Y equals whatever this value is. The k value is negative 1. So y equals negative 1. As you can see, the current asymptote is at negative 2. So we need to move it to negative 1. Simply move it up there to negative 1. After that, you're going to do a quick XY table. Plug in some 2 easy numbers like 0 and 1. Let's start with 0. Plug in 0. And again, you can do all this math with the calculator. Well, if you have a 0 right here, anything to the 0 power is 1. And 1 times negative 4 is negative 4, and negative 4 minus 1 is negative 5. So when you input 0, you get out a negative 5. And again, you could type in negative 4, open parenthesis, hit the fraction button, put a 1 over 2, close parenthesis, and up here you could, on the exponent, you could plug in a 0, and then get off of the exponent position, hit minus 1, all on a calculator, hit equal, and it'll give you negative 5, okay? So 0, negative 5 is the location of one of our points. So I'm going to take the one that was at 0, 0, and I'm going to move it to 0, negative 5, which is down here. And then from there, I am going to plug in another easy number like 1. Plugging in 1, 1/2 to the 1 is 1/2. And 1/2 times negative 4, half of negative 4 is negative 2. So the whole thing's negative 2, and then minus 1 is negative 3. So when I plug into 1, I get out a negative 3. And again, the calculator could do that for you. Now I just need to move this point to 1, negative 3. So I'm going to just move it from the origin. 1 on the x, negative 1, 2, 3 on the y, put it there. And that's all you got to do. With that asymptote and with those points, Wayground will graph the exponential decay function for you. Now, why did I say decay? Well, first of all, the base is less than 1. That's a decay. Not only that, from left to right, the distance is decaying towards the asymptote. I hope this helps, guys.